Hi everyone. Today we're gonna look into solve problem 7.44 in homework 6. And our goal for today is to find the inductance L that make the source current I of t in phase with source current Vs of t at a frequency of omega equal 10 to the power 4 radians per seconds. And at first, there's something we gotta know is that when the current and the voltage are in phase, the circuits is at resonance, meaning the total impedance of the load is purely real. No imaginary components, it's allowed. And let us dive into this question. And let's start with the first part. Alright, so we can see that there's two resistors and one capacitor and one inductor. Let's convert our components into a frequency domain with the given omega. All right, start off with the capacitor. All right, so the formula for the reactance for the capacitor is going to be ZC is equal to negative J over omega C. All right, plug this into the calculator, and we are going to get negative 25 imaginary resistance. All right. For the inductor, the formula is going to be Z of L is equal to J omega L, which is equal to J 10 to the power 4 L resistance. Alright. And as you can see right here, we have 50 ohms and 25 ohms. And judging by the circuit's orientation, these components are in parallel, meaning that we can combine them using the special formula Q, which is R2O1 over R2 plus R1. Alright, and since R2 is 25, R1 is 50, R2 is 25 plus 50, this is gonna give us around, plug it into the calculator, it is roughly 16.67 resistance. Alright. Now, let us define the total impedance for the circuits so that we can concatenate everything, so we can separate the real part away from the imaginary part. And since every single component is in parallel, including the inductor, capacitor, and resistance, we can sum it up with this equation right here. So total impedance is equal to Req, and parallel with the capacitor, ZC, and which is also in parallel with the ZL. Alright, and before we continue any deeper, let us simplify it a little bit. Alright, let's start off with finding the value of ZC parallel with ZL. Alright, this we can do it probably pretty easily. This is just going to be Z25 times J 10 to the power 4L over J25 plus J 10 to the power 4L. And this is going to give us a value of J, and J is negative 1. 1 times negative 1 is 1. Oh, this is 25. 10 to the power 4, that's 40 with an L. And the same for the numerator, which is going to be J25 plus J 10,000 L, of course. Alright, and now let's make this entire components. I'll call this ZCL. parallel with ZREQ. Alright, so this is going to be a long number. Let's work it out. L times 16.67 over 25,000 L over J25 plus 10,000 L plus 16.67. Alright. And using the magical calculator to somewhat simplify this equation, we are going to get roughly around 11.54 squared over F2 minus 0.0015 for L plus 0.000002 plus, oh, actually minus the imaginary part, which is 0.019 L for L minus 1 over the same denominator. And this is equivalent as 11.54 squared over the same denominator minus J 7.68 squared minus 0.019 L over the same denominator and resistance. Alright, and like I said earlier, in this equation, it's asking for us the value of L so that I of t is in phase with Vs of t, which means that the imaginary part has to be 0. So this means that -0.68 squared and minus 0.019 L over the same denominator has to be equal to 0. Alrighty. Alright. And we're just gonna do some basic algebra here. And this is equivalent as negative 7.68 squared plus 0.019 L equal to 0. And let's take 0.19 out. 0.019 L. Take out a minus sign. And we have 400 L minus 1 equal to 0. Alright, so this gives us two scenarios. First one is this one. This one is just going to give us L equal to 0. Hands per minute. And this part right here is going to give us L equal to 400 L minus 1, which is equivalent to equal to 0, which is equal to 400 L equal to 1. L is equal to 1 over 400, which is equal to 2.5 millihenries. Alright, and these two are the answers to our questions. Alright, so for the inductance to be in phase, the inductor value is either 0 or 2.5 millihenries. Yay! Alright, I hope this tutorial helped you tackle the problems in Circuit 2, especially Homework 6, 7.44. And yeah, that's about it. Thank you for watching.